And here's your EB6 calculator. All right. And if you look at this thing, if you slide the card out for a second, you'll see that there's a transparent window here on a wheel that turns. Okay? Now, you're going to plug your numbers into this and manipulate it to give you the answers that you want. And I'm going to show you how you do that right now. Very, very easy. Okay. The first thing I always do, and it really doesn't matter why, just trust me for now, is you want to take this slidey card here and you want to position the number 100, the arc that represents 100 in the middle. You want to put that right under the hole in the center of the wheel here, okay? You just want to, that's your starting point, that's your 0 point. Okay. We look at the question, and you're going to do this every time, by the way. You're going to do the same execution every time. First, you look at the true course, which we found to be 12 degrees. So what you do is where it says true index here, you put under true index 12 degrees. Okay, so you have 12 degrees under the true index. Make sure, again, that the 100 arc is under this little hole here. Okay, once you have that, you put 12 degrees here, you go back to your sheet here, and it says that the wind speed is 25 knots. So you want to count up 25 knots on the scale here. And the way you do that is you just pretend that each one of these little arcs is 2, and each one of these thick arcs is 10. So to get to 25, it would be 2, 4, 6, 8, 10. So we know each one of the thick ones is 10, so we can just jump. This is 10, 20, 22, 24, and between these two lines must be 25. So you want to put a dot, 2, 4, right where the 25 would be. And you just take your pencil and write it on that surface. It's designed to take the pencil mark and then be erased later. So you counted up 25 boxes to on the straight line from the 100 point up to 25 knots. So that's all you do, is you see the number 25 under wind speed, and you just count up 10, 20, 2, 4, 5, and that is your wind speed graphically represented. Now, the next thing you do is you look at the wind speed that was given. I'm sorry, the wind direction that was given, and you turn the plotter to the wind direction to 330. So we turn it to 330, and you'll notice that the mark we made with our pencil actually moved, okay? So that moved somewhere over here. The next thing you do, now that this is moved over here, is you look at the true airspeed. And the true airspeed in our worksheet is 100 knots. So all you do is take this dot right here, and you move it, or I should say move the card until the dot is sitting on the airspeed, the true airspeed that they gave you in the question, which in this case is 100 knots. So I don't know if you could see my dot here, but I'm moving it right onto the arc that says 100, okay? It doesn't matter why we do it, just know to do it, because it's the same thing over and over again. There's no more thinking than this. Once you have your dot lined up with the 100 arc, all you have to do is read the number of the arc that's in the hole here. So I can see that it's falling, to me, it looks like it's falling just on the 80, just on the arc that has the number 80 on it. So that is your ground speed. Your ground speed will be in this little hole here. So your ground speed is equal to 80, okay? Actually, 80 knots. So now you calculated the ground speed. Now you have all your variables. All you have to do now is simply plug the numbers you found into my formula here. And here's how simple it is. The distance you already found with your plotter to be 60 nautical miles. So you take 60 nautical miles, divide it by the ground speed, which is 80 knots. Then, in every calculation, you're going to multiply it by 60 minutes. Okay? That's going to give you an answer. So you take your calculator and you just plug in 60 divided by 80, gives you a number, usually a fraction, 0.75, multiplied by 60 minutes, gives you 45 minutes. Now the way I set up this formula, your answer will always be in minutes. But remember, they added the departure time and the climb out time of 3.5 minutes in the beginning of the question, in the end of the question. So you just have to add the 3.5 minutes in. They don't always add time, but in this question they did. So you add 3.5 minutes to the answer. And so the real answer becomes 48.5 minutes. Now, let's look at the possible choices for our answers. And you got to pick the closest one. Okay, so we got 48.5 minutes. Well, there's a 52 minutes. We know that's out. 44 is close, but 48.5 is closer to 48. So 48 minutes is the answer. And let's see if we're correct. And sure enough, the answer is B. Now, why isn't my answer exactly 48 minutes like it is in the question? And I'll tell you why after having done a bunch of these. There's a couple of reasons. One, they may be purposefully making it a little blurry so that it forces you to think, because the real world isn't perfect. Second is that when you actually do your calculations, your measurements, that you do may be one tick mark off. Okay, that's reality. Nobody measures the same every single time. Even the print on the charts, certainly in this book here, may not always be the same. It may not be accurate to within a millimeter. And if it's even off, if my image in my book is just 1 millimeter larger than the image in your book, there's going to be a discrepancy in the accuracy. Not to mention the plotters. There may be a little discrepancy in the way the scale of the plotter was made. Another thing, and there's room for a lot of error, is when you're using the calculator here, because you're using a pencil to make a mark, and there might be a millimeter of distortion in the mark. Bottom line is there's plenty of room for error, and they know that. So your answer does not have to be 100% close to theirs, just close enough. You have to pick the closest answer. 52 clearly isn't anywhere near 48.5, and while 44 minutes is closer, 48 minutes is a lot closer to 48.5. So that's why we pick the answer B. So you just fill out the sheet, force it into the formula I made, come out with an answer, and find out which one is closest to the answer here. And that's your answer. Okay, we'll do another one.